Okay, welcome to the very last of the moderate videos in Introductory R for Economists. After this, we'll be going into slightly more advanced things that you can probably get by without, but you know, hey, it'll be good to know. In this video, what we're going to be looking at is missing data, how to handle missing data in R if you happen to have some in your data set. Now, most of the time, I suspect, in your classes anyway, when you're handed a data set by your professor and told to do some, econometrics on it, that data set will probably be ready to go out of the box. It's not going to have any missing data in it unless you're trying to estimate a Heckman model or a Tobit. But sometimes, maybe they want you to have to deal with some missing data, or they don't even realize that the data set they're handling you has some missing data in it. And what I mean by missing data is you've got a variable and there's some observations in there that you don't know what they are, right? They're missing, they're not in the data set, okay? So how are we going to be able to deal with this? So first of all, let's load in some data. Now, the data sets that we've been working with haven't really had any missing data in them. So let's load in a data set that I downloaded from the College Scorecard, which includes data on colleges that you can get on the College Scorecard website. Tells you about colleges. I'm going to read this in as a CSV file like we did way back. You'll notice I've also included an option here, strings as factors equals false, because I know that there's some string data in here, some non-numerical data with letters and stuff like that. And by default, by the way, read.csv will read those in as though they're factor variables. But I don't want them to be factor variables. I want them to be string or character variables. So I'm going to say, don't read them as factors, read them in as strings. So I'm going to go ahead and read that in. And I'm going to be interested in looking at the relationship between the average SAT scores of a college's incoming class and the number of undergrads. So basically, do bigger colleges have lower entering SAT scores? Just a random thing. But let's go ahead and look at our scorecard data. So if we look around at some of these variables, we're going to see, oh, there's null values in here. Now null is not an official missing indicator in R. It just happens to be in this data set, missing values are recorded as null. But if I do this, if I say, okay, I want to look at the SAT scores and I want to look at the number of undergrads, they're currently as string variables because you see we got some letters in there, so I got to convert them to numbers. So let's use as.numeric as we did long ago. So let's say that scorecard SAT average is going to be the as numeric version of scorecard SAT average, and also scorecard number of undergrads is as numeric scorecard $ number of undergrads. Now this is going to turn them into numbers, and those characters, the null word there, that's of course not a number, so it's going to have to say, I don't know what this is. This isn't a number. I want to make this missing. It's an NA. And there could be NAs for any reason. And you'll notice we get some warning messages here. It says NAs induced by coercion. We had some string variables. I told you to turn them into numbers. You can't really do that. So instead, you're going to treat them as missing. So let's look at our scorecard data again. And if we look over to our SAT average variable here, you'll notice we have some NA values, right? And NA is R's official missing indicator. If something is equal to NA, that means that you know that it is missing, and R will know to treat it as missing, okay? So we have our missing values in there, so we're going to turn data into numeric, which gives us some missing values. Okay, so now we have some missing observations in there. Now, what can we do? Now, there's a problem. Now, let's say that we want to, say, calculate the mean of one of these variables. Well, R is going to have to make a decision about how it's going to treat all those missing observations, right? Is it going to just ignore them like they're not there? Is it going to, try to average them in some ways? Is it going to try to predict what they are? Is it going to give you an error term? Now, what it's going to actually do is going to depend on what command you're actually using, okay? So, for example, if I just run a regression model, it's going to go ahead and ignore those missing values. It's going to basically take every observation that has a missing value and toss it out. It's going to ignore it entirely. So if I do a regression, SAT on undergrads, I do this, it'll be totally fine with it. And when I do a summary of my SAT on undergrads regression model, it ran just fine right? No problem there whatsoever. You'll notice that some of these observations in here are deleted due to missingness, right? It can't include them in there because it knows, I mean, it's a missing value. What can I possibly do with this? Now, for a lot of commands, it will know, or it will just automatically drop any observations that are missing. This is called listwise deletion. Now, there are some pros and cons to taking this particular approach to missing values, but probably at the undergrad level, you're not going to be doing anything other than this, where you're just dropping values that are missing. If you get more advanced, you can do things called like multiple imputation or limited information maximum likelihood, but you're probably not doing that today. So, now this is fine. However, some commands will not do this. They'll give you an error term. For example, if we want to take the mean of the average incoming SAT, this is going to give us an error term, right? Because it says, I'm not going to ignore those missing values. I'm going to include them, but I can't include them. So here's a missing observation. Now in this case, now if you run across a command that works like this, where you try to put it in and it gives you a missing response because you have some missing data in there, there are a couple of things that you can do. Often, these commands will have an option that tells it what to do with missing observations. Often this is na.rm or na.omit. And if you set those to true, it will know to just omit them, as happened with the regression model, where it just sort of tossed them out the window, right? We didn't do anything with them. Now, which one goes to which command, na.rm or na.omit? It depends on which command it is. Look at the help file. With mean, we're going to do na.rm equals true. Do that. Now, this time it will actually report a mean for us, okay? Now, let's say that we are working with a command that will give us a problem if we give it some data with missing values in it, but also, for some reason, the na.rm command or na.omit command is not working, or it's not there, whatever it is. And so in that case, what we might want to do is understand, first of all, what's going on with our missing data, and then get rid of it, okay? So first of all, if you have missing data, it's a really good idea to know what's going on with it. So let's load in Stargazer, because Stargazer is actually going to be helpful here. Load in Stargazer. Now, Stargazer, as we know, will give us summary statistics, right? And one of the summary statistics it's going to give us is the number of observations. And it doesn't count the missing observations when it does that, okay? So if I say, give me Stargazer, and I want to feed in just those two variables from my scorecard data, I'm going to use, of course, subset. If I do this, right, so you can see here, this is telling me that there are only 1,420 non-missing observations of the SAT variable, and there are 7,090 observations that are not missing of the undergrads variable. So immediately, at a glance, I know, oh, I have a lot of missing observations for SAT, and I have a few missing observations for undergrad. So I can see over here, in total in the data set, there's 7,804 observations. So I've got most of those with undergrads variable, but not a huge chunk of them for the SAT variable, right? By the way, if you have a variable that's missing a lot of observations, that might be a problem. You might want to rethink your analysis there, or figure out something to do about it. Now, we might also want to limit our data set to just the observations that are non-missing, okay? There are a couple of things we can do with this, or there are a couple of ways that we can do this. So you might remember, first of all, the is.na command. We actually used this before. We used this with the censored data, in the censored data video, to run our Heckman model. Right? So what this is a function. If I feed it a variable, it will tell me whether or not it's missing. If it's missing, it will give me a 1. If it's not missing, it will give me a 0. Okay? If I want to flip those so that it gives me a 1 if it is not missing, and a 0 if it is missing, then I just put an exclamation mark for not. Not is missing, right? Okay, so one thing that I can do is I can use subset to just select the observations that are not missing, all right? So I could say create a non-missing data set, okay? So let's do not miss scorecard. I'm going to use subset here to just select the observations in subset that are not missing SAT AVG. Okay. Now, of course, I could do this as well for the undergrads variable because that has some missing observations as well. But of course, I'd have to type out every single variable. There's a slightly simpler way with the complete cases command. Create a data set with no missing observations. Okay. So nothing missing .scorecard. That's going to be another subset. But instead of saying I can't have you missing SAT average, I'm going to say complete cases of scorecard. Now what that's going to do is that's going to go through the scorecard data set, and it's only going to keep observations for which none of the variables are missing. Not just SAT average and undergrads, but none of them. It's going to look through every single variable, see if any are missing, and then drop them if they are missing. Okay, if I do that, nothing missing, that's going to limit me to 1420 observations. Now, of course, you know, if I'm only running, if I say I want to do this complete cases thing before running a regression, but I'm only using some of the variables, I might want to, you know, I might not want to drop it just because it's missing some random variable that I'm not interested in. So for that, of course, I would use the select part of subset. No missing observations within the variables I'm using. Okay, so in this case, I'm just going to do select SAT average and undergrads. So this is going to, of course, limit it to just those two variables, and then it's going to just select the complete cases within that data set. All right. Now, in this case, it didn't make any difference because if anything's missing, SAT is missing, whatever. Anyway. All right, this is the basic way in which we can deal with missing data. You're probably not going to come across this too much in your undergraduate classes, but you might deal with it if, for example, you're doing a thesis and you're working with your own data. Often, with times, we'll have missing data in it. The most common way to deal with missing data is to simply drop all the observations that are missing. There are some problems with this, but you're probably not going to deal with those problems at the undergraduate level. You're just going to go ahead and do it. A lot of commands will do it automatically for you. For the ones that don't, you can either use their na.rm or their na.omit options, or you can limit the data to just the non-missing stuff beforehand by using the complete cases command. All right, that's it. I will see you in the advanced videos if you come along with me. The scary stuff. See you there. Bye-bye.